This graphic organizer shows how we can classify matter. Again, we can classify matter as either a pure substance or a mixture. A pure substance can either be an element or a compound. An element is the simplest form of matter. Elements can combine chemically to form compounds. Again, compounds are made up of two or more elements. And then we have mixtures. Mixtures are combinations of two or more pure substances. A mixture can be homogeneous or heterogeneous. Homogeneous mixtures are also known as solutions. Meanwhile, heterogeneous mixtures are colloids and suspensions. Again, the difference between the two is that uh, on their composition, it's on the distribution of the components and the other component in the mixture. So for homogeneous mixture, it has one visual appearance because it has uniform composition. So it has uniform or even or pantay ang pagka-distribute ng one component in the other component in the mixture. Let's emphasize this using the following examples. This one is a mixture of salt and water, so it's composed of salt and water. But here I cannot see the components or I cannot see the particles of salt because the particles of salt is evenly distributed. Again, evenly. So even, pantay ang pag-distribute ng salt particles in the solution. So this will have a uniform composition. So this one is a solution. So again, a solution is a homogeneous mixture. This one, at first sight, this may look like a solution because it has one visual appearance, one texture, one form. But if I look this one under a microscope, I can still see the uneven distribution. I can still see the particles of some components in the mixture. Now this one is a colloid. Now this one, so I can still see the particles of the other component in the mixture. I can see this even without a microscope. I can see this with my eyes. This one is a suspension. Again, colloids and suspensions are heterogeneous mixtures. Heterogeneous, heterogeneous mixtures. Now let's go back to the graphic organizer. We have here guide questions that will help you identify whether this is this given type of matter. Let's take for example salt water. So salt water is composed of salt and water. Salt and water. Now how do I separate this one into its components, salt and water? I can do that by of course boiling this one. So of course boiling or evaporation, that one is a physical change, right? Physical change, physical change. Let's answer the question, can it be physically separated? Again, our given matter here is salt water. Can it be physically separated? Again, yes, I can boil this one. That's a physical change. So this one is a mixture. Now, is the composition uniform? So again, this one is a homogeneous mixture. So the salt particles are evenly distributed on the mixture. So this one is yes. So salt water is a homogeneous mixture or is a solution. Let's have another example. Let's have water. So of course water, when you try to separate it, it's actually composed of two elements, hydrogen and oxygen. Hydrogen and also oxygen. Now how can I break water into hydrogen and oxygen? Can I simply boil water into hydrogen and oxygen? Of course, no, I cannot boil this one or break this down using boiling alone because it's not enough yung energy ng boiling to separate this into its constituent elements. Now, I can turn this one to this one by using chemical reactions, by chemical means. So again, let's go back to the question. Can it be physically separated? The answer is no. I cannot separate this one by simple physical means. I can only separate this one using chemical means. And this one is a pure substance. Next, can it be chemically decomposed? Can I break this down into other substances? Again, I can still break down water into hydrogen and oxygen. So this one is yes. So therefore water is a compound. So again, it's composed of two different elements. Now let's try to see how we can separate water into hydrogen and oxygen. So here I can separate water by the process of electrolysis. I can run an electric current in the water, and this energy is enough to break down or to break the bonds between the particles of oxygen and hydrogen. Again, H2O or water is something like this. So the particles of oxygen and hydrogen are held by a strong chemical bond, and I can only break this one using enough energy. And again, here the energy from the electric current is enough to break this bond, so I can separate the oxygens from the hydrogens. Let's see how this experiment will work in this video.
I'm going to show you an electrolysis of water setup. So we have a mini Hoffman apparatus, and I'm going to take this little test tube here, and I'm going to dip it under and fill it completely with a 3 molar sodium hydroxide solution. I'm going to do the same with this one. So since we're starting with that completely filled up with solution all the way to the top here, it's going to allow us to collect gases in each of those. So we're going to run a red lead to the negative terminal of the battery, a black lead to the positive terminal. And when we do that, you can see bubbles starting to originate in there. I'm going to zoom in so we can see that up close. And that gas is collecting on the left and on the right, over there. So we're going to let that run until we've collected enough to make a measurement. So let's go ahead and make a measurement here. So we're going to start by unclipping this. That way our reaction will slow down and stop. We'll let some of those bubbles collect. So we're going to tip this over. Now you're in a little bit of a parallax there, so this is currently reading about 3.7, 3.8.
Okay, so let's pause this one. By the way, so here these are two gases. So one of this contains hydrogen and the other contains oxygen. Now, which one do you think is the hydrogen and which one do you think is the oxygen? Again, if we look on the chemical formula for H2O, it says here H2O. So it says here that for every one amount of oxygen, I have double the amount of the hydrogens. And over here, we can see that this one is double the amount of this one. Again, this one, so this one is empty space because this is occupied by the gas. Then this one is also occupied by the gas formed by this reaction. So obviously this one is the hydrogen. So again, it's double the amount of the oxygen in the reaction.
Milliliters for the smaller of the two. And the larger of the two is currently at about 7.6, maybe 7.7. Okay, so 3.8, 7.6. Looks like we have twice as much gas on the one side than the other. Let's hook these back up so we can fill them up a little bit more. So now we need to test what those gases are. So to do that, we're going to do a simple splint test. Let me zoom out a little bit. So our test tube on our left here.
Okay, on this part, we are starting to check whether these are really a different element because this might be just vapor from the water. So here we're going to check what type of elements are present on this space over here.
the one that's filled up with more. We're going to test that first. We're going to let the other one go for a little bit while we do that test. So to test that, what we're going to do is we're just going to pick it up and we're going to insert a flaming splint into it, see what it is. So this is the one that has more gas present, looks like about twice as much gas. So we're going to let the solution pop out of there. Okay. And so from that noise, we know that we have hydrogen gas present. So now we want to do a test on the other one to see what gas is present over there. And keep in mind that we're only testing about a half-filled container here, so we're up to about 4.5 milliliters of this other gas. What we're going to do here is we're going to test to see what this is. The splint is ready. We're going to put that flaming splint into there. And we can see that that lit back up, which is indicative that we have oxygen gas present. So what we ended up with was 3.8 milliliters of oxygen gas and 7.6 milliliters of...
Okay, so that shows how we can separate the components of water uh, from this process. Okay, so again, that's how we can classify the different forms of matter. So it can be either a mixture, a pure substance, and then for the rest, just copy this one on your notebook. Let's discuss about the different separation techniques. So again, we can separate the components of a mixture based on their differences on their properties. Let's start by this one. This one is a suspension of salt of sand and water. How do I separate the sand from the water in this mixture? I can do that by filtration. So I can do that using a strainer, or I can use a filter paper. So this one is a filter paper, then I just put it on this funnel over here. So here I can filter this one because they have different particle size. So here the particles of the sand is large, that it cannot pass through the pores of this one. So again, here the basis for the separation is the particle size. So they have different particle size. So that's for the filtration. The next we have this one. This one is a mixture of rocks and sand. Now, what type of technique can be used for this one? It can still be a filtration, but in this case, the term will be sieving. So it's like filtration, but again, for the filtration, this one is when you filter a solid from a liquid, then sieving pag solid to solid. So it's still based on the particle size. So on this case, since again yung particle size ng sand kay smaller, it can pass through the pores of this sieve over here. This is also used on baking. Next we have this one. Let's go back to this part